Good morning to all of you. Today we discuss about question paper JEE mains question paper which is conducted on 28th January 25th in the first session. Okay, all the questions asked from first year concepts. Okay, the first question is, in a measurement it is asked to find modulus of elasticity per unit torque applied on the system. The measured quantity has dimensions of m power a, l power b, t power c. Value of c, that means if c is equal to 3, the value of b is, this is asking. So what is given in a measurement? It is asked to find modulus of elasticity per torque. What is it? Modulus of elasticity. Modulus of elasticity per torque. This is given. Then find the b value. Okay. You know, modulus of velocity is equal to what? Stress by strain. Torque is equal to force into distance. Force into perpendicular distance. Okay, but you know, stress is equal to what? Force by area. Force by area. Okay, by strain means what? Into strain. Okay, into what? Force into distance. You know, this force is cancelled. Strain does not having any dimension formula because strain is equal to change in dimensions by original dimension. So what is remaining? The remaining equal to what? 1 by area into distance. You know, 1 by area means what? Length into breadth. Both are measured in meter. Meter is unit of length. Length is represented by L, so L square. Distance is L. So what is that? 1 by L cube, which is equal to L power minus 3. L power minus 3. So the value of B is equal to what? Minus 3. Okay? Right. This is the answer for this. Okay? Right. Okay, the second question. A tiny metallic rectangular sheet has length and breadth of 5 mm and 2.5 mm respectively. Using a specially designed screw gauge which has pitch of 0.75 mm and 15 divisions in the circular scale, you are asked to find the area of sheet. In this measurement, the maximum fractional error will be x by 100, where x is equal to how much? This is the question. Okay, asked in this exam. So what is given once again? A tiny rectangular metal sheet. Suppose this is a tiny rectangular metal sheet. Length is equal to something, breadth is equal to something. It's all given. L is equal to 5 mm. Breadth is equal to what? 2.5 mm. These two are given. That's it. Using a specially designed, you want to calculate its area. You may use screw gauge, but the screw gauge is specially designed, which has a pitch of 0.75 mm and 15 divisions in the circular scale. So, what is the least count of the given screw gauge? Okay, least count of given screw gauge. LC is equal to what? Pitch by number of divisions in circular scale. Number of divisions in circular scale. Therefore, least count. What is the pitch of the screw? 0.75 mm by how many divisions are in a circular scale? 15 divisions. So 15. So what is the value? 55 is assigned for. That means 0.05 millimeter is the least count of this screw gauge. So by using this instrument, you want to calculate its cross section area. Okay, in this measurement, the maximum fractional error occurred while calculating its area using this screw gauge of least count, this one. Fractional error is delta A by A is equal to, you know, what is the area of this sheet? length into breadth. So what is the possibility? Delta L by L plus delta B by B, isn't it? But because area is depends on length and breadth, while you may change either in L, A is changed, either in B, A is also changed, because area is depends on length and breadth. So which is equal to delta L. This is the maximum possible value of error by using this one. That means what? 0.05 by length. What is the length is given? 5 plus what is the breadth? 2.5. 2.5 by 5. Sorry, 0.05 by what? 2.5. 0.05 by 2.5. Okay, so you get the value is equal to what? 1 by 100, isn't it? 5 into 10 power minus 2 by 5. 5 cancel, 10 power minus means what? 1 by 100. This is also, you get 5 5s are 125. That means which is plus what? That means which value is equal to 2 by 100. That means what? Yes, 2 by 100. While calculating it, that means what? 0.05 by 2.5 is equal to 5 into 10 power minus 2 by 25 into 10 power minus 1. 5 1 ja, 5 5 ja. So while when go to this side, 10 power minus 3. That means what? 10 power minus 3 by 5. That means 1.5 means what? 0.05. That means you get 2 by 100. Okay, so the value is equal to what? 3 by 100. Compare it with given value. What is the given? X by 100. Therefore x is equal to what? 3. X is equal to what? 3. So this is the answer for this question. Okay, right. The third question. The center of mass of a thin rectangular plate, sides of length A and B. This side A, okay, length A and side B, whose mass per unit area sigma varies as sigma is equal to what? Sigma naught x by AB, where sigma naught is a constant. Okay, it would be how much? So what are the coordinates of the center of mass? Okay, so you want to calculate center of mass of this rectangular plate. You may take a small element, okay, of length what? Dx, of length what? Dm, which is the distance x from the origin. Okay, so here first you want to calculate center of mass component on x-axis. You may define sigma is constant in y-axis. That means here let's say mass per unit length. What is that? Mass per, okay, linear. That means areal mass density. Sigma is constant on y-axis. On what? On y-axis. Okay, so y center of mass is obviously what? Center. That means where it is a b by 2, obviously. So center of mass component along the y-axis is obtained directly, but mass is vary, okay, on x-axis. That's why it is given, whose mass per unit area sigma varies as sigma x by A into B. Along the x-axis, okay, mass per unit area is changes. Okay, so you want to calculate that value. So for variable mass system, okay, what is the center of mass is equal to integral from what to what? From minimum to maximum. It means 0 to A. Here to see, its mass is start from 0, maximum area is nothing but length is equal to A. So A, x into dm by integral 0 to A dm. Okay, so here x is what? Here x is equal to what? X is the length. X is the length from origin. So it may be write what? Integral 0 to A x into sigma, isn't it? X into what? Sigma. Why we can take mass is equal to volume into density, means area into area into density. So sigma into d, area, by integral 0 to a sigma into d. But here sigma is given. What is the value? Sigma naught x. Therefore, it is integral 0 to a x into sigma is equal to what? Sigma naught x by ab into area. What is the area of this small element? What is that? B into breadth into dm. Breadth into what? Dm. Isn't it? Okay, that mass is equal. So it is nothing but what I say, breadth into dx. Breadth into what? Dx. Okay, by integral 0 to a sigma x ab into what? B into dx. Isn't it? So here to see, here sigma naught by take a, bb is cancelled, taken as common, take outside because both are constants, so take outside integration. So what is remaining? 0 to a x square dx, because x into x square dx, by in this denominator also bb is cancelled, sigma naught, sorry, this is sigma naught by a integral 0 to a x into dx. X is remaining, so these two are cancelled. Then remaining what? Integral 0 to a x square dx by integral 0 to a x dx, which equal what? X cube by 3 0 to a by x square by 2 0 to a integration. Okay, you know in the integration x for n x equal to n into x for n plus 1 by x into n plus n by 3. X for n is equal to x for n plus 1 by n plus 1. So you get a cube by 3 into 2 by a square. So that may equal to 2a by 3. So the components are, what is that? Therefore, x center of mass comma y center of mass coordinates are equal to what? 2a by 3 comma what? b by 2. So this is the answer for this question. Okay, right. The fourth question, assertion reason type. What is given? In a certain in a central force field, the work done is independent of path chosen. You see, in a central force, what is a central force? First of all, central force. Central force. Okay, what is central force? You know, the force which is act on any object along the line joining that body and that part. What is that? Central force is a force which is always act along the line joining them. For example, gravitational force, okay, spring force, electrostatic force. These are the best examples of what are the central force. Okay, so central force is mathematically represented as minus du by dr. That means they are depend on position. When position changes, okay, central force is also changes. Force is a vector quantity, so either change in magnitude or in direction, it may changes its energy. Okay, that means because force is change, because force is a function of position. Okay, so according to assertion, in a central force field, the work done is independent of the path followed. Here to see, when position changes, force magnitude is changes. So it is a so central force is conservative force. Central force is what? Conservative force. So conservative forces are independent of path followed. So assertion is correct. Next one is what? Reason R. What is it? Every force is encountered in mechanics does not have an associated potential energy. Yes, it may be correct. It's straight away a statement of potential energy. That is, in every force is encountered in mechanics does not have an associated with the potential energy. Yes, it is correct. But there is no exact relation between this assertion relation. So what is the exact answer for this question? Assertion, reason both are correct, but reason is not correct explanation of assertion. Okay, that's it. Okay, the fifth question. A bead of mass m, suppose to say this is a bead its mass is what? M. A bead of mass M slides without friction on the wall of a vertical hoop. This is a vertical hoop, okay, whose radius is R, okay, which is attached to a fixed one, okay, which is shown in the figure. The bead moves under the combined action of gravity. Here to see, this is the bead is attached to a spring constant K. Its mass is negligible. That is given in the question. What is that? The bead moves under the combined action of gravity and massless spring K attached to the bottom of the hoop. The equilibrium length of the spring is R. Equilibrium length of the spring is what? R. If the bead is released from the top of the hoop, now the bead is released from the top of the hoop with zero initial velocity. So what is the speed of the bead when the length of the spring becomes what? R. When the length of the spring becomes what? R. This is asking. To see, this may be right like this. To see, whenever the bead is released, whenever it is at the top of this circular hoop, it possesses only potential energy. This is due to gravity as well as spring. So, from work energy theorem, okay, from work energy theorem, what is that? Total energy at this top point, okay, before it is releasing, due to its potential energy, it possesses kinetic energy. Okay, he is asking what is the speed of this hoop after released from rest while it is reaches to the bottom, which is the length is equal to what? R of the spring. So it may be connected like this way, which is when you can length is R. This is also equal to what? R. So which is equal to what? Above is 60 degree. So what is the total length? R plus R cos theta, isn't it? What is it? R plus R cos theta. So what is the total potential energy to topmost point? Equal to total kinetic energy while it is reaches at a particular point, which is equal to length equal to R of the spring. So what is that energy? Potential energy at top equal to kinetic energy at a length equal to R of spring. This is the condition is given. So what is the potential energy? What is the potential energy? mg into R plus R cos theta. Okay, this is due to potential gravity. Okay, here what is given? The bead starts moving with the gravity as well as spring constant. That means what is spring potential energy? 1 by 2 K into R square is equal to kinetic energy. What is that? Half m v square. Okay, right. So see this mg into R plus R cos 60 plus half K R square. This is nothing but what I say? Kx square. That means what? Spring potential energy of m v square. So which is equal to what? Mg into R plus cos 60 means what? R by 2. Okay, plus half K R square is equal to what? Half m v square. Okay, therefore what is the value? 2r plus 3 mg R by 2 plus K into 1 by 2. On both sides 2 is cancel. 2 is cancel. Then you get 3 mgr plus k r square is equal to half m v square. Sorry, this is equal to half is cancel. That implies v square is equal to 3m. So sorry, this is capital M. Mass. Term it may take, no problem. This is m. So what is that? 3 mgr plus kr square by m. Okay, what is v square is equal to? But he is asking me, that implies v is equal to under root. This m is cancelled. That is what? 3gr plus kr square by m. This is the velocity of this bead. Okay, right. Right, the sixth question. The moment of inertia of a solid disk rotating along its diameter is 2.5 times higher than the moment of inertia of a ring rotating in similar way. Okay, next one is the moment of inertia of a solid sphere which has same radius as the disk and rotating in similar way is n times higher than the moment of inertia, okay, of the given ring. Here n is equal to what? Okay, to see the first condition, there are two statements are given. According to the first statement, what is that? The moment of inertia of a solid disk. For example, first you can say this is a disk, okay, which is rotate about its diameter. Suppose it is rotate about its diameter. Okay, this is a disk. Okay, its moment of inertia about the diameter equal to what? I1. So the moment of inertia of a disk about its diameter. So suppose this is the radius of this, okay, disk. So what is the moment of inertia of a disk rotating about its diameter, which is equal to what? M r square by 4. That means what? M r1 square by 4. Okay, next it is compared with the moment of inertia of a ring. Next one is what? This is the ring. It is also rotate in the similar way. So the moment of inertia of this ring is called I2. That means moment of inertia of a ring, I of ring, is equal to m r2. Here to see this is the radius of this ring. So what is that? R2. So what is the moment of inertia of a ring about its diameter? M r square by 2. It means m r2 square by 2. Okay, this is the condition. What is that? Here to see the moment of inertia of a disk I1, moment of inertia of a ring is I2. Therefore, what is given? The moment of inertia of a solid disk rotating about its diameter is 2.5 times higher than the moment of inertia of a ring. Okay, so what is given in this question? Okay, that means I'll discuss it. I1 by, so suppose this is 1, this is I2 is equal to 2.5 times. What is the 2.5 times? From this one you can write I1 is equal to what? M r1 square by 4 into, okay, 2 into m r2 square is equal to what? 2.5. From this one you can get this m is cancelled, this 2 is cancelled. When 2 is brought onto this side, it implies what? R1 square by R2 square is equal to 5. This is the equation 1. So from first sentence we get this R1 square by R2 square equal to what? 5. Okay, next, what is that? The moment of inertia of a solid sphere which has the same radius as the disk. Next one is what? Disk. This is the disk. It is also rotate in a similar way. Its moment of inertia equal to what? I3. So what is the moment of inertia of a disk? Solid disk. Okay, what is that? 2 by 5 m r square. What is that? 2 by 5 m r square. Okay, right. But its radius is equal to what? R1. Its radius is equal to what? Sorry, equal to R. What is it given? The moment of inertia of a solid sphere which has same radius as the disk. What is the radius of the disk? Equal to what? R1. So it is nothing but what I say? M R1 square. M R1 square. Therefore, the ratio I3 by I2. That means moment of inertia of a disk to ring is n times, equal to what? N. Okay, so I3 is equal to what? This is the disk. Moment of inertia is equal to I3. That is that 2 by 5 m R1 square into R2. That means I2 is the ring. What is that? 2 by m R2 square is equal to what? N. So to see this m is cancelled. 2 2 is 4. 4 by 5 into R1 square by R2 square is equal to what? This is equation 2. But you know from equation 1 what you get? R1 square by R2 square equal to what? 5. Therefore 4 by 5 into 5 is equal to n. This 5 is cancelled. Therefore n is equal to what? 4. Okay, so you get N is equal to what? 4. So 4 is the answer for this question. Okay, right. Right. The seventh question. Two iron solid discs of negligible thickness having radii R1 and R2 and moment of inertia I1 and I2 respectively. For R2 is equal to R1, the ratio of I1 and I2 would be 1 by x. Then x is equal to what? This is given. What is that given? Two iron solid discs. Suppose to see this is the first iron solid disc. Okay, it is rotate about any axis. For example, this is the first iron solid disc, first disc, whose radius is R1. Rotate, whose radius is what? R1. Rotate about an axis which is passing through its center. For example, okay, it is moment of inertia equal to what? I1. So what is this moment of inertia I1 is equal to what? M R1 square by 2. This is the moment of inertia of a disc rotate about an axis passing through its center. Okay, so what is it? I1 is equal to M R1 square by 2. Second one is what? Second one is also iron disc. Suppose it is also rotate about an axis passing through its center is nothing but what I say I2. Its radius equal to what? R2. So what is its moment of inertia? I2 is equal to M R2 square by 2. Here to see, in this question there is nowhere discuss about their masses, but their thickness is negligible. So I don't know the mass of first disc. So its mass is equal to M1. Second disc mass is called M2. But what is the hint is given? Given R2 is equal to what? To R1. So the radius of the second disc is equal to 2 times of radius of the first disc. This is given. But you don't know the M. So what is the M1 is, mass is equal to volume into density. What is that? Sigma into pi R square. So first disc is radius equal to what? R1. So sigma into pi R1 square. It is called M0. For example, say second disc of mass is what? M2. So its mass is equal to what? Sigma into pi into R2 square. But R2 is equal to what? To R1. So sigma into pi into R1 is equal to what? 2 R1 square. So sigma into pi into 4 R1 square. It may write like this: 4 into sigma into pi R1 square. But sigma into pi R1 square is equal to what? M0. Therefore, M2 is equal to what? 4 into M0. So masses are given, radius is coming. So therefore, according to given question, what is that? I1 by I2 is equal to M1 R1 square by 2 by M2 R2 square by 2. This 2 is cancelled. Then M1 R1 square by M2 R2 square. M1 is equal to what? M0. R1 square equal to what? R1 square by M2 is equal to what? 4M0. 4 into M0 into R2 is equal to what? 2R1. That is given in this question. It is what? 4 R1 square. So this R1 square, this R1 square cancel. This M0 is cancelled. 1 by 4 into 4. That means what? 1 by 16. So compare this one. The ratio of I1 and I2 would be 1 by x. Therefore x is equal to what? Therefore x is equal to what? 16. So answer for this question is equal to what? 16. Okay, right. Right, the 8th question. In the experiment for measurement of viscosity, that means coefficient of viscosity of a liquid with a ball of radius r, consider the following statements. Okay, that means while you are calculating this coefficient of viscosity of a liquid by using a ball of radius r, some parameters are given. From these parameters, okay, you may select the correct options. Okay, to see to calculation of coefficient of viscosity of a liquid by using a ball which is dropped in a vessel containing liquid whose coefficient of viscosity is supposed to be calculated. Okay, you are getting an equation by using the Stokes law. This is a ball. Okay, when it's dropped into this liquid of coefficient of viscosity eta. Okay, you get what is that one from Stokes law. Stokes law. The radius, that means the terminal velocity of a liquid, the terminal velocity of a ball in a liquid of coefficient of viscosity eta and density d, of density rho. Okay, and this is the ball density is supposed to be d. Okay, E is given by an equation 2 by 9 into r square into g by eta into d minus rho. This is an equation obtained by using Stokes law. Okay, what is it? The terminal velocity is equal to 2 by 9 times of radius of this ball into gravity, which is divided, okay, with the coefficient of viscosity of this given liquid into d, density of the ball minus density of the liquid. So from this one you get first option. What is it? The graph drawn between terminal velocity, okay, and r. How rated terminal velocity and r both are directly dependent. That means the terminal velocity is directly proportional to square of the radius of the given ball. So when you draw a graph between this one, it is nothing but a parabola. That means Vt is taken as y-axis, radius is taken as x-axis. So the graph is nothing but a parabola. So it is correct. Next one is what? The terminal velocities of different diameter balls are constant for a given liquid. You see, the terminal velocity is depends on r, what? R. Okay, so what is going? The terminal velocity of different diameter balls are constant for a given liquid. No, it is not correct. So it is wrong. Okay, that means radius is changes, ball diameter is changes. So it is terminal velocity also changes, but it is opposite given in this second option. So it is wrong. So third one is what? Measurement of terminal velocity is depend on the temperature. Yes, it is very, very correct. Why? Because when temperature rises, coefficient of viscosity of for a given liquid is decreases. Okay, so it is correct. Okay, right. Next, D. This experiment can be utilized to assess the density of a given liquid. Yes, from this one you can easily calculate the density of a liquid. It is one of the method. So D is also correct. Next, option E. If balls are dropped with some initial speed, the value of eta will changes. No, it is not correct. Okay, right. So it is wrong. So from this given option you can select A, C, D. This is a multiple option question. So from this question, in this question, option A, C and D, these three are correct options. Okay, right. Right, the ninth question, consider following statements. From these statements you can choose the correct one. Okay, this is a multiple option question. Okay, right. Multiple correct question. First statement, surface tension arises due to extra energy of molecules at the interior as compared to the molecules at the surface of a liquid. To see, surface tension is a molecular phenomenon. Okay, what is surface tension? The free surface of a liquid acts as a stretched elastic membrane. Okay, so the surface tension arises due to molecules of that liquid only, where they are present, whether interior or exterior, it is not matter. Okay, so the option, the surface tension arises due to extra energy of molecules of the interior. The interior molecule doesn't have no any extra energy. It is same. Okay, that means molecule of a liquid having same kind of energy. Okay, but not surface molecules have more energy compared to interior. Interior molecules have more energy compared to exterior. It is not correct. So option A is not correct. Next, option B. As the temperature of the liquid rises, temperature of the liquid is what? Rises. The coefficient of viscosity is what? Increases. It is completely opposite. It is wrong. What is it? When temperature rises, molecules distance increases, which is decreases the viscosity of that liquid. Okay, so it is wrong. Next, option C. As the temperature of gas increases, the coefficient of viscosity is what? Increases. You know, there is a confusion word. When temperature is increases in liquids, viscosity is decreases. But in case of gases, when temperature rises, coefficient of viscosity is what? Increases. That is correct. Okay, that means gas molecules are come closer. That's why viscosity of the gas is increases while increases their temperature. Next, option D. The onset of turbulence is determined by using the Reynolds number. Reynolds number is meant for what kind of liquid it is, whether it is flowing like a streamline, turbulent, like that. So, based on Reynolds number only, we can find out that flow is streamline or turbulent. So, option D is also correct. Next, option E. In a steady flow, two streamlines never intersect. When streamlines, that means the fluid is flow like streamlines, no two streamlines are intersect with each other. When they are intersected anyway, at that point of intersection having two different directions of motion, it is never possible. So that no two streamlines are intersect. So option E is also correct. So in this given question, option C, D, E, these three are correct one. Okay, right. The 10th question, assertion reason type. Assertion is a sound wave has higher speed in solids than gases. The speed of sound in solids and liquids is given by root over P by rho. P by rho. When more the pressure, more the speed of light in that medium. Compared to gases, in solids, molecules are very close. So when you apply a pressure, it is equally distributed in all the points. That's why in gases, pressure is less, so that speed is less. But in case of solids, more pressure, then more the speed. So that a sound wave has higher speed in solids than gas. Yes, assertion is correct. Next one is that reason. What is that reason? Gases have higher bulk modulus than solids. What is a bulk modulus? Delta P by delta V by V. Okay, gases having less bulk modulus. Gases having less bulk modulus compared to solids. So reason is wrong. So assertion is correct, reason is wrong. So this is the option for this question. That means what? Gases have less bulk modulus than solids. Actual statement is. Okay, right. The 11th question. For a particular ideal gas, which of the following graph represents the variation of mean square velocity of the gas molecules with the temperature? That means while you are drawing graph between temperature with the mean square velocity of gas molecules, what is the nature of the graph? From kinetic theory of gases. What is that? Root mean square velocity is equal to root over 3 RT by M. What is that? Root mean square velocity equal to what? Root over 3 RT by M. Okay. From this one, V RMS, that means square on both sides. What is that? 3 RT by M. That means mean square velocity. That means square. That means V square RMS square mean square velocity is directly proportional to T. So when you draw a graph, you must get Y is equal to what? Mx form. That is nothing but a straight line. So from this one, option 1 is correct. That's it. Okay? Right. At the 12th question, what is that? A Carnot engine E works between two temperatures, 473 Kelvin and 273 Kelvin. In a new system, two engines, engine 1 works between 473 K and 373 K. And engine E2 works between 373 Kelvin to 273 Kelvin. If eta 1, 2, eta 1 and eta 2 are the efficiencies of engines E1 and E2 respectively, then it means what is the relation between Carnot engine E and Carnot engine E1 and Carnot engine E2 relation, efficiency relation. The efficiency of Carnot engine, the efficiency eta of a Carnot engine in terms of temperature, eta is equal to 1 minus Q1 by Q2. Okay, for engine E, efficiency, what is that? Eta 1 2 is equal to, okay, right, what is it? 1 minus, it is working in between 473k and 273. Okay, so what is the value? 273 by, sorry, q2 by q1, sorry, q2 by q1. Okay, that means q1 minus q2 by q1. Okay, so eta is equal to minus q2 by q1, so 273 by 473. So when you get this value 273 by 473, approximately we get the value is nothing but 473 minus 273 by 473 is equal to 200 by 473, approximately 0.4 times. It's 0.4 approximately. I would like to approximate. Okay, right. Next, efficiency of for engine E, efficiency for engine E1. For engine E1, efficiency eta 1 is equal to 1 minus. Okay, E1 works between 473 and 373. That means 1 minus 373 by 470 equal to what? 473 minus 373 by 473. That means what? 100 by 473. It is half of that one, isn't it? It is half of that one. That means what? 0.2 approximately. I would like approximate. Next, for engine E2. Okay, its efficiency eta 2 is equal to what? 1 minus. Second one is working in between 373 to 273. That means 1 minus 273 by 373. You know very well, heat engine is working in between source, sink and working substance. Okay, right. 373 minus 273 by 373 is equal to what? 100 by 373. While you are calculating approximately 0.2, approximately, remember approximately. Okay, but according to this one, it is very clear there is a relation between them. Eta 1 2 less than eta 1 plus eta 2, but here to see eta 1 2 equal to n1, eta 1 plus eta 2. But while you are calculating in points, the answer may be vary. So we may very cautious while doing it. Is nothing but 2 1. While taking second decimals also, it is nothing but it is 2.26 approximately, I would like to say. So you can do carefully. Therefore you can write eta 1 2 value of 4 6 approximately 473 428 428 and 8, for example, to 8. And that is while you are going to the third term also, we get 0.42 not 8 1 2 3 4 6. This is nothing but 3. While calculating is nothing but 1. While we are calculating, this is equal to 2.68. So when you do it, eta 1 2 is compared to both more than that, and then it's what? 1 2 eta 1 plus eta 2. So option 1 is the correct one. While calculating 0.479, isn't it? Which is sum of these two less than is greater than this one. That means what? This is less than sum of these two. So option 1 is correct for this. Okay, right. Thank you.